Hello everyone, it's Felipe again, and today is the first code review that will go through the rule-based A example. And first of all, I'm going to show you how this code is organized. And you see that in the examples folder, if you don't know, we have all the examples here. The examples folder, the player rule-based A, we have 4 files. The main file is player rule-based a.py that you should use in the config.json file to run this example, the sample code. And we have 3 more files here. In the helper, functions that can help like calculating the distance, velocities are located. And do you remember that I explained that the rule-based algorithms are divided in strategy and control? The strategy part is located in the players.py file, while the control part is located in the action.py file. So let's go to the code, and it's going to be interesting because I'm going to revise that with you guys here recording. So let's see how it goes. So the player rule-based A is where our code communicates with the AI soccer simulator and receives the relevant information about the game, and also send back our actions to move our robots and also to kick and to jump and do this. At the beginning here, we have the import of the library, so we import the libraries that we use here. Important libraries are the NumPy for numerical computation, and you see that here we also import the helper, so the helper functions are also used here. So from our strategy that's located in the players.py, we import our goalkeeper strategy, the defender 1 strategy, the defender 2 strategy, the forward 1 strategy, and the forward 2 strategy. After that, we define our constants that we have in most of our codes in our sample code. So we have the reasons when the game can reset, like when the game started, when a score happens, when a deadlock happens, a goal kick, a corner kick, a penalty kick. And also we have our game states. The usual game state is the default that happens like during the game, but we also have the kickoff, the goal kick, the corner kick, and the penalty kick state. And here we put some constants that help us develop our code and also make our code more readable. That is how to get our coordinate information. So if I want my team coordinates, I'm going to use this constant here, my team, opponent team, ball, and XYZ orientation, that's T8. If my robot's active, if my robot touches the ball, or if my robot has the ball possession. You know that we have the frame that we receive at each time step that consists on the current score, the reset reason, the current game state, the image, the coordinates, and if it's first or second half. Okay. Here the class player is our main class that we inherit from the class participant that we provide. And there are 3 important functions here: the init, the update, and the finish function. So the init is called before the game starts, and you receive the information about the robot, about the field, the dimensions, the maximum velocity, everything you receive in this info dictionary in the init function. So that's the first one that is called. And then we have the update one that we receive the frame that I call here the received frame, and after the game finish, we also have the finish function that I'm not using here because I'm not doing anything after the game is finished, but you can use to save your files and model, for example. So let's go, and before the game starts, the init function. The init function is called and we receive the information, the info. We should save the information that we need in our variable. So here we save the field information in the self.field variable. We save the information about the linear velocity, the maximum linear velocity. We save the information about the robot size. We save the information about the goal dimensions, about the penalty area dimensions, about the goal area dimensions, about the number of robots, that here is 5. And also we initiate some variable that's important, that is the end of frame variables, that it's going to tell us that we receive all the information in each time step. We're going to use that later. And here we're going to initiate some variables that we're going to use later. The speeds is where we're going to save our variables to control the robots, and this list is the one that we send back to the simulator. So this self.speed is really important. And also we get variables to save the information received in each frame, like the current posture of our robots, the current posture of the opponent robots, and the current ball. And we also start, because we're going to save the previous ball, and we're going to try to predict where the ball is moving. This IDX and IDX opponent we're going to use to calculate our robot that's the nearest from the ball, and also the opponent robot that's the nearest from the ball. And also we're going to start here a defense angle and attack angle that we're going to use, for example, to calculate our defense position for our goalkeeper. And the index for the robots, the GK is 0, the D1 is 1, the D2 is 2, F1 is 3, and F2 is 4. And then we know that we have the classes that implement our strategies. We initiate our classes here. We initiate our goalkeeper, we initiate our D1, we initiate our D2, our F1, and our F2. Going to get this class that will return us later the actions that we should take at this time step. So let's go here to the update function, that this function is called at each time step. So we receive the frame. After we successfully receive the complete frame, that this flag end of frame is true, we can start our logic here. So we count that our frame is counted +1, and if it's the first frame, we do not have previous frame because this is the first one. So the previous frame receives the current frame, and we call the get coordinates function. In this get coordinate function, we just assign the current ball position and the current posture of my team and the current posture of the opponent team from the received frame. So here is like, it's not the first frame, we get in this loop. So we get the coordinates, that's the same function that I explained, and we get important information to do our strategy. So we calculate 5 things that will help us to define our strategy. This is the predicted ball, that is the predicted position of the ball. We're going to see this function in the helper later. And then the IDX, that is our closest robot to the ball. The IDX opponent, that's the closest robot from the opponent team. So you see that here we pass the information regarding the opponent team. The defense angle, that's the angle between the ball and our own goal. And the attack angle, that's the angle between the ball and the opponent goal. And to get the actions here, we call the move functions of our strategy. So say like, okay, I want to get the actions for my goalkeeper. That is here for the first 6 index of my speeds list. So I call like, please goalkeeper, move. And I give him the information. I give him who he is, that is his index, the robot that's closest to the ball, the opponent robot that's the closest to the ball, the defense angle, attack angle, the posture of my team, the posture of the opponent team, where the ball was, where the ball is, and where the ball will be. I give this opponent. And I do the same thing to get the actions for the D1, D2, F1, and F2. After I receive it back, all the speeds, I can send back to the simulator. So I call the set speeds. You always need to call the set speeds to send information back to the simulator, and I send this list. And I update my previous frame and my previous ball, and I finish my update loop. And with this, I conclude the player rule base A code. You see that here I just have the initiation of this code where I got my player class and I just run, so then I can get the init, update, and finish functions as I explained. In the helper, we see that we start again importing the libraries. The important library that I used in this helper is just the math library. So again, I get the constants that help me and make my code more readable. You're going to understand, especially when developing the strategy. And here I calculate the distance between 2 points, for example, the conversion between the degree and radian, the conversion between radian to degree, and I also do some wrap to pi where I limit my angle. Here I have my predict ball function. So I'm predicting the ball for the next time step. So see that the prediction step is 1. So I calculate the current ball with the previous ball and try to predict. There are other ways to predict the ball, and you can use like bigger, larger time steps, and you can try also to like predict where the robot and the ball are going to intercept each other. You're free to do that. Here is my function where I calculate the closest robot to the ball. I send the ball and I send the posture of the robots, and it calculates the distance. Here I'm not, if the nearest one to the robot to the ball is the goalkeeper, I'm bypassing and I'm giving that it's actually the defender, just because the goalkeeper is not influenciated if he's the nearest from the ball or not in his strategy. Also, I have additional helper functions to know where the ball is located, if it's in my own goal, if my own penalty area, if my own field, the opponent goal, the opponent penalty, and the opponent field. And the two ones to calculate the angle, the defense and the attack kick angle. The defense angle calculates related to my own goal, but the attack kick angle calculates regarding the opponent goal. And I have another helper function set wheel velocity that's just used if my controller gives a wheel value for a velocity value that is more than my maximum linear velocity allowed to my robots. I scale down, so I give values that can actually be executed in the simulator. And I have the print console function. This helps you to debug your code. So you can use the print console message to see messages in the Webots console, and the print debug flag that we also provide for you, we're going to check soon, that show where in your strategy loop you are executing, where in your strategy, like in the logic, which part of your strategy you are executing at the moment. And this finish our helper. So now we are going to the players. where the strategy is implemented. I chose to go through this rule base A because it's the simplest one. So we are going to check how you can develop your strategy. The code starts importing the libraries again, but now you see that I import not only the math but the helper that I presented to you, and also the action that is where my controller is implemented. Here I have my constants that help me throughout my code, and the first class that I'm going to present is the goalkeeper class, what the goalkeeper should do depending on the current state of the game. First, when I start my goalkeeper, I receive the information that I need to calculate my strategy and to implement my strategy. That is the field specifications, the goal specifications, the penalty area, the goal area, the robot size, and the maximum linear velocity. I assign this to the variables in this part, and also initiate my flag that I'm going to use for debug purpose. And the strategy is implemented in this move function, where I receive the information that I presented to you from the player rule base A, and I should define my action. So here, for the goalkeeper, I give to him the protection radius, that is which radius he should use to calculate the defense position. So I got that I use the goal area here with a small threshold to defend the goal. And the angle that I want to defend is the defense angle. So with these two, the radius and the angle, I can calculate my protection position for the current moment. So my protection x is going to be the cosine of my defense angle times my protection radius minus my own goal in the x-axis. The protection y, use this sine of this angle as my protection radius. So you see that the logic for the goalkeeper is really simple here, because it doesn't matter where the ball is. If the ball is in my own goal or in my own penalty or in my own field, in the opponent goal, in the opponent penalty, or in the opponent field, that you see the different flags here, I'm going to do the same thing. I'm going just to protect against kicks. So my x position is my protection x, my y is my protection y for all the cases. So right now what I have here is that I have my xy position where I want my goalkeeper to move. You should remember here that actually I have a cross kick and kick pass. All of here are set to false. That is the actions that I can take. So when I define, you remember that I need to send back 6 variables. So the left wheel and the right wheel are going to be dependent on the XY position. So how I calculate this? With my controller. So the left wheel, right wheel is going to receive my controller here, the action go to, and I send the X and the Y position, and also where my robot is located right now, his maximum linear velocity. But to kick, I'm going to get my front slider values. So I'm going to calculate the kicks based on my flags, these 3 flags. So if I want to cross, I'm going to set the cross to true, so he's going to attempt a cross, for example. For jump, I need to send a jump action to calculate my bottom slider. Here is the bottom slider. And the dribble mode, if it's active or not, I'm going to send the dribble flag. As this is really simple, I'm just concerned about going to my X and Y position. So after I receive the left wheel, right wheel, slider horizontal, slider vertical, slider jump, and dribble mode, I have my 6 continuous variables that I should send back, so I can return my strategy. So I return the 6 values here. So now we are going to the defender. The defender is doing the same thing here. In the init, I initiate my variables, use my flag, my debug flag that you see here in the loop, and my defender is doing the same thing, like it's moving only to one position. Doesn't matter what happens in the field. And with the position, I can calculate my 6 variables using my controller and send back. Defender 2 and Defender 3 are similar, but what changed here now is the class for our second attacker, forward 2. For our forward 2, we initiate our variables, flag, but for the move, we have something that's a little bit more complex. It's not that complex as a rule-based B example, for example, but it's already starting to get more complex, and I'm going to tell you how. So if the ball is in my own goal or my own penalty, the F2 just position himself in the X minus 0.5 and Y minus 1. But if the ball is our own field, we try to chase the ball. So I give to him that X is the current ball, Y is the current ball Y. And if the ball is in the opponent goal, like really near the opponent goal, I also say to him, like, go to the current ball position, X current ball X, Y current ball Y. And if you have the ball possession, you try the kick pass. You just try to put this ball inside the opponent goal. And if it's the opponent penalty, what I'm going to try is also go to the ball, but if I have the ball possession, I'll try a cross. And if it's in the other side, in the opponent field, if it's in the opponent field, I try to go to the current ball, and if I have the ball possession, I try the shooting here. So here we have all the flags. So now you see that I'm activating the kick flag, so I can shoot, I can cross, I can perform a kick pass. So I'm also getting something different here from this action kick. So I use my slider, my front slider is activated in some situations, you see here. In this situation, the front slider is activated. So I use my controller and I send back my wheels. And finally, the end here, I'm going to present you the controller. So in the controller, I import my libraries. Here I just import the math and the helper. Again, the constant values here. And you saw that for the players, I usually call the go-to, kick, the jump, and the dribble. So see that I have the go-to here, the kick, the jump, and the dribble. The go-to is the most complex function, is that based on the current posture of the robot and the X and Y that I want to move to, I should define my left wheel and right wheel. And what I use is a controller based on the error. between the distance between the current position and the target position, and the orientation that I need to achieve that position. So the distance error is this dE variable, and the error in orientation is dGH variable. So using these two, I can calculate the left and right wheel. So here you see that I have a KD that is a constant for my distance error, and KA that is a constant for my distance in orientation, that this should be tuned. But the idea is that if the distance is larger, if the distance to the target position is larger, I need like a higher linear velocity to achieve that position. And if I have an error in orientation, I should rotate until I have the right orientation to achieve that point. So that's going to give me the left and the right wheel. I also have some go fast here, is because you can imagine that when I'm really near the ball, I'm really near the target position. So this dE is really close to 0. But actually, in some occasions, I also want to go fast in these situations because I want to move fast, for example, in relation to the opponent goal. So I also have this go fast option that is activated in some situations that are good for soccer specifically. The kick is the one that I can define the cross, the shoot, and the quick pass. So the cross is where when I use my front slider with maximum velocity and also put the threshold so they can kick high. The shoot is also like with front slider with maximum velocity, but I try to kick the ball. No, I do not try to kick the ball high, and the kick pass is just with half of the front slide velocity to try to kick to other robot that's in the better position than me. The jump, I jump if the flag is true, I jump with the maximum range here, the slider range. And if the dribble mode flag is true, I activate the dribble mode. With this, I finish my code review, and let's see if we can see this code in action. Let me see if I can show you guys. I'm going to try to put here. And you see that here we have our AI soccer simulator in Reboot. And I'm going to try. So the player rule base A is going to be our team A. So if you want to change the team, you need to come here and change this executable and put the team you want. The team B can be your opponent. In this case here, we're just playing against the random walk example that we provide. And all the other variables are the default. Each have 5 minutes, the deadlock's activated, and repeat, multi-view, record, and replay are all false for this case. And we're going to see that in some situation we should change this, but for now it's just this. So it can run here. And we see that our robot is chasing the ball. It's just trying to chase the ball. Let's see if I can move him and the ball here. Yeah, so he's going to try to chase the ball. And here you also can see the flag that's being activated in the code right now. So F2 is 8. So let's see what is 8 in F2. Let me see if I can get 8 in F2. 8 in F2, he's just chasing the ball. So you see that he's just chasing the ball, and it makes sense in the behavior that we are observing here. just trying to chase a ball. Now that we've changed it, now it's in our on field, the flag also changed here. Penalty area 2, before when was in our on field 3. So you can use that to design your robot. He's chasing the ball one more time, but now he's not going to kick, he's just trying to chase the ball. Maybe if he gets to the opponent field, he's going to try a kick situation. Let's see if he can move. Yeah, he tried the kick situation, you just saw that. Like a shoot situation. Again. Okay. So with that, we finish our first code review session. I hope you enjoyed, and see you in the next review session.